Hey there, students. This clip we're going to go over some examples to get you ready for the test. I just want to commend you for taking the time to go over this. Hopefully you do well on the upcoming test, okay? All right, let's take a look at question number one. All right, we're supposed to find an identical expression for sine squared x plus cotangent in times cotangent square x plus 1. So let's write it down here. So we have sine square x times cotangent square x plus 1. So what we're going to use is we need to change this using the Pythagorean identity. So if you consult your Pythagorean identities on this table of trig identities, which you'll be provided with on the test, you notice we have a Pythagorean identity that matches cotangent square x plus 1, which is this variation right here. You notice that cotangent square x plus 1 equals what? Equals cosecant square x. So what I'm going to do is I'm going to replace cotangent square x with cosecant square x, its Pythagorean identity. So we're going to have sine square x times cosecant square x. Okay? Now to simplify further, remember cosecant is a reciprocal identity, right? So what do you reciprocate to get cosecant? Let's consult our identity table again. Cosecant is 1 over sine. Okay, so I can replace this cosecant with its reciprocal identity, which is 1 over sine. But since we're squaring it, we're going to have sine square x times 1 over sine square x. Okay, because cosecant is 1 over sine, so if you square this, you square that also. And what happens is these two divide out to 1, and your final answer is just 1. So our answer to number 1 is option B. Alright, moving along. Question 2, which of the following accurately shows y equals negative 2 cosine x? So let's write this question down. I'm going to write this in transformational form. So it's going to be y minus 0 equals negative 2 cosine 1 times x minus 0. Okay? That tells me that the new origin is 0, 0. Since the new origin is 0, 0, the phase shift, which is the side-to-side shift, is none. Okay? The vertical shift is none also, because you have 0 for your x and y. Remember, this is your phase shift right here, and this is your vertical shift. Okay? Since they're both zeros, then there's no shift in those directions. My amplitude is the absolute value of a, which is basically the absolute value of negative 2, which is 2, which means I'm going to be going 2 units up and down. And my period is 2 pi over b, which is just 2 pi over 1. Since b is 1, this is b right here, 2 pi. Okay? All right, so we have 4 options to look at here. So we can use, let's say we know it's centered at 0, 0. Okay, so let's graph the center on the 4 options we have. There goes the center, there goes the center, there goes the center, and there goes the center. Okay, remember sine is your s going up from the new origin, wherever that is. Negative sine from the new origin is your s going down. Cosine is what? Your cup, right? From the new origin, you start from the math and you form a cup. And negative cosine is a cup that's flipped upside down, right? So we go like that. So which applies here? In this case, we have a negative cosine. A negative cosine. So we can use method of elimination to tell. This is sine. This is negative sine because there's an s going down. This is a upside down cup. This is negative cosine. And this is cosine. So you can clearly see that our answer is option C. Okay? Everything else is wrong because those are not what we want. This is negative. This is the only negative cosine curve. We can see the amplitude is negative 2 centered around 0. And the period is 360 degrees, which is the same thing as 2 pi. Okay? So there you have it. Alright, moving along. Question 3 says evaluate cosine 7 pi over 4. In this problem, we're going to be making use of our common angles table, which you're going to be provided with. So let's take a look at that. Cosine 7 pi over 4. So all we just need to do is mark 7 pi over 4. So I'm going to grab this. Just give me a minute. Alright, so we're looking for cosine 7 pi over 4. Let me just write that here. So all you just do is you just use your two fingers to trace where the angle and the trig function meet. Okay? So this is cosine where we're starting from, and we're looking for 7 pi over 4. Where are you? Over there. Where do they meet? So you can put one finger on the angle and go down, and then one finger on the trig function and go to the right. Where do they intersect? They intersect at root 2 over 2. Okay, so wherever the angle and the trig function intersect, that's the value. So cosine 7 pi over 4, which is the same thing as, what is that, 315 degrees, is equal to root 2 over 2. Alright, so our answer is option B. Alright, let's move along. What is log base 3 of 81? So to do this, remember that if the base and the arguments match, they cancel out, okay? So the question is, can I express the argument as a power of the base? Remember, you can never change the base. The base stays the same, except you want to use the change of base formula, which is not applicable here. To reduce it, we need to just express this as the power of the base, alright? So we take 81 and start decomposing it using the base. Hopefully it works out. I take out 3 from 81, I have 27. Take out 3 from 27, I have 9. Take out 3 from 9, I have 3. So 81 is basically 3 to the 4th power. So log base 3 of 81, I can write it as log base 3 of 3 to the 4th power. Now we're going to use the exponent, the inverse property of logarithm. Alright, so using the inverse property of logarithms, we know that these two are going to cancel each other out. The exponent and logarithms are inverses, so these cancel each other out. And you're left with 4. Okay, so answer to question number 4 is C. Alright, let's move on to question 5. It says a photographer points a camera at a window in a nearby building from an angle of 49 degrees with a camera platform that is horizontal to the ground. So we have a camera platform on the ground, and the cameraman points the camera upwards, obviously, to a window that's 49 degrees above the up from the horizontal. So this is 49 degrees right here. The camera is 53 meters, so this is the camera right here. The camera is 53 meters from the building. How high above the building is the window? So let me write my labels in such a way that it's easy to see. So this is my camera, and this is the window. And right here is like you have the building right here. Okay? Alright, so you're standing, the camera is 53 meters away from the window, so the question is how long is this? So we're looking for this length right here, how high the window is. So this is right triangle trig because we have our angle and 2 sides, and then we have a right triangle right here. So we're going to be using SOHCAHTOA. So the question is, what trig function are we using? Is it going to be sine, cosine, or tangent? By labeling what we have, what we need and what we know, we can figure that out. Okay, so we need this side right here is right opposite the angle, so that's the opposite. That's O. This is the adjacent, and the side opposite in 90 degrees is your hypotenuse. Okay, the hypotenuse, we don't know it, we don't need it, so we just scratch it. What we care about is O and A. Which trig function has O and A? Tan does, so we're going to use tan. Okay, so tan 49 equals x over 53. To solve this trig in algebraic equation, we just multiply both sides by 53. And then we have x equals 53 tan 49 degrees. Okay, so just plug that into our calculator. Alright, so make sure that your mode is in degree form first before you start computing this expression. So I already put mine in degrees, so we have 53 tan 49. And the answer is 60.97 degrees. So the angle, the height, the height is 60.97, all right, meters. So the answer is B. All right, moving along. Question 6. Find x round to the nearest 100. So this is a right triangle trig problem again. This is your reference angle, which makes this side your opposite. and this is my hypotenuse, and this is my adjacent. So am I going to use, which one am I going to use? Sine, cosine, or tangent in SOHCAHTOA? This is sine, cosine, or tangent. Notice adjacent, you don't need it, you don't know it, so let's scratch it. O and H, which is O and H, sine, so we're going to use sine, okay? So sine 37 equals opposite over hypotenuse, alright? To get x by itself, you multiply both sides by 22. Let's divide out. So x is going to be 22 sine 37. So just plug that into your calculator. Let's look at what that is. 22 sine 37. The answer is 13.24. Okay? So 13.24 is the value of x. So answer is B. Alright, number 7, it says evaluate secant of the inverse cosine of 1 over root 3. What you have to remember here is that secant is a reciprocal of cosine. Okay, you just have to remember the reciprocal identity, which tells you that secant x equals 1 over cosine x. Okay, so if I use that here, I can express secant of the inverse cosine of 1 over root 3 as, this is the same thing as 1 over, change secant to cosine, inverse cosine of 1 over root 3. Okay, because secant is reciprocal of cosine. Now you notice these two are inverse functions, so since they're inverses, they cancel each other out. So you're going to have 1 over root 3. So if you have a fraction in the denominator, you can write it horizontally. 1 divided by 1 over root 3. And then drop, change, flip, or multiply by the reciprocal of the denominator. So it's 1 times root 3 over 1. Multiply it out, so your answer is going to be root 3. Okay? So there you have it. Alright, moving on. Okay, the answer is, is number 7 is D. Okay, number 8. It says find the identical expression for this expression right here. So we have cosine x minus sine x squared. Sine x, the whole quantity square, minus 1. Alright, so let's use let's follow this out using the properties of algebra. So we have cosine x minus sine x multiplied by cosine x minus sine x. Okay, minus 1. So we're going to do typical foiling first, outer, inner, and then last. Okay, we'll multiply cosine and cosine. That gives us cosine square x. Cosine and sine, negative cosine x sine x. Sine and cosine, negative, we can write it as cosine x sine x because multiplication commutes. And the last one is plus sine square x minus 1. Okay, so let's condense it further. We have cosine square x minus 2 cosine x sine x plus sine square x minus 1. And then we can commute this sum right here to the cosine. So write it as cosine square x plus sine square x minus 2 cosine x sine x minus 1. Okay, now what is cosine square x plus sine square x? If we go back to our table of identities right here, we notice that cosine square x and sine square x equals 1. So cosine square x plus sine square x or sine square x plus cosine square x equal 1. Okay, so this whole expression right here can be reduced or condensed. This one can be condensed into just 1 because it's equal to 1. Alright, so 1 minus 2 cosine x sine x minus 1. Alright, because, let's write the reason here, because sine square x plus cosine square x equals 1. So that's what justifies my replacement here. Okay? Alright, so now if I combine 1 and negative 1, it would add up to 0. So the final answer is going to be negative 2 cosine x sine x. Okay? So the answer is option D for number 8. Alright, moving along. Number 9 says draw the angle in standard position and name the reference angle for 100 degrees. So let's go ahead and draw that. So it's a positive angle, so we're going to be going counterclockwise. Remember, this direction is positive, and the other direction is negative. Okay, so we were trying to figure out what quadrant 100 is. So every quarter of an angle, quarter of a quadrant of a full circle is 90 degrees. So first quadrant is 90. Too small, keep going. 180, too big. So that tells me that 100 degrees is somewhere here. Okay? Alright, so that's 100 degrees. But the question asks for where is the reference? What is the reference angle? This is 100. What's the reference angle? Remember, the reference angle is the measure of the terminal side to the closest x-axis. Okay? So since we're right here, this is the closest x-axis down. That goes your reference angle. So how many degrees of separation between 100 and 80? Is 80 degrees of separation. Okay? So let's see which one matches what we have. Option letter letter C. Alright, moving along. Question 10, give the amplitude and period of the graph. Amplitude is the measure from the center to the max or center to the mean. Okay, so if I'm going center to max, right here, that's the amplitude. So how high do I go from the center to the max? The max is 6. So in this problem, the amplitude is 6. Okay, or if you wanted to do center to mean, this is the center right here to the minimum, and there goes it. All right, if you don't understand what the max and mean are, this line right here is your min, this is your center, and this is your max. Okay, you always measure from the center, always measure from the center. Okay, so this is the max, and this is the center, and this is the mean. So the amplitude is the distance from here to here, or the distance from here to here. Okay, that's the A, and that's A also. Alright, so in this case, amplitude is 6. What's the period here? This is obviously a cosine function because it's a cup. So how long is a complete cup? The complete cup is 4 pi units wide. Okay, so for the period, we're going side to side. So how wide is this? It's 4 pi units for a cup. Remember, a sine is an S, that's the period of a sine. And for a cup, cosine is just like a complete cup right there. Okay? So this is for cosine. So since a cup is 4 pi units wide, the period is going to be 4 pi. So that tells me that the answer is option D. Alright, moving along. Question 11 says find the identical expression to this. So we have cosine t over 1 plus sine t. So I'm going to multiply by the conjugate, okay? Why am I multiplying by the conjugate? I'll tell you in a minute. So 1 minus sine t times 1 minus sine t. Alright, well, you notice if I multiply 1 plus sine or cosine by its conjugate, I'm going to end up with one of these identities right here. So let's look at it. Notice for sine, you have a cosine and its conjugate. The product of 1 plus cosine and its conjugate gives you sine squared, and then for cosine, the same story. Since you have a product of sine and its conjugate giving you cosine square x, and the same story here also. Okay? Alright, so that's what we're going to be. This is the whole reason why you multiply by the conjugate. If you have 1 plus sine or 1 plus cosine, because you can always change it into something else. Okay? So that's why I'm multiplying by the conjugate. And the numerator doesn't change much. The numerator is simply cosine t times 1 minus sine t. And then the denominator is 1 minus sine squared t. Okay? How did I know that? 2 ways. You can either FOIL it out, 1 minus sine t times 1 plus sine t. If you FOIL it out first, you get 1. Outer becomes negative sine, inner becomes, outer is negative sine and inner is positive, outer is positive sine, inner is negative sine. Those cancel out, and then your last is positive sine squared t. Okay? If you don't want to waste time following it out, you can simply refer to your table of trig identities. It tells you here clearly that 1 plus sine t times 1 minus sine t equals 1 minus sine squared t. Okay, so you can just use this as an identity, use this as a shortcut. All right, so that's what we have. So now we're going to use another identity, which tells me that 1 minus sine squared t is equal to cosine squared t. So cosine t times 1 minus sine t. So the identity is that 1 minus sine squared t equals cosine squared t. Okay? And that identity is the same one we've been looking at. 1 minus sine squared t right here is equal to cosine squared t. See this identity right here? That's what we're using. Alright, so let's go ahead and use that. So you notice we have this right here. So we're going to do, this is going to become cosine t times 1 minus sine t. And then I can write the denominator as a product of 2 cosine t times cosine t. These two divide out. And your final answer is going to be 1 minus sine t over cosine t. And the answer is option letter B. Okay? Alright, moving to question 12, where to convert 450 degrees to radians. So when you're converting, you need to just remember that your conversion factors are pi over 180 degrees, or 180 degrees over pi. Okay, radians, okay? So one of these two conversion factors is appropriate for this problem. So we have 450 degrees. Let's put it over 1. Which of them am I going to use? Well, I want the degree gone, so I pick the one with the degree in a position where I can cancel this on the top right here, okay? So since there's a degree on the top, I'll pick the one with the degree on the bottom. Pi over 180 degrees. This is radians. So this is the angular measure I want on top here. So the degrees cancel out, as you can see, and then the zeros divide out. So we're going to have 45 pi over 18 radians. I can reduce this by dividing top and bottom by 9. Divide by 9, top and bottom. So that's going to give me 5 pi over 2 radians. Okay? So the answer to number 12 is B. Alright, moving right along. Number 13, simplify 27 raised to the by third power. So this is a rational exponent problem. So to do that, we can express this as a power, and then we can use the power of power property to simplify this, okay? So let's express 27 as a power. So let's decompose it completely into its prime factors. So 3 goes into 27 9 times. 3 goes into 9 3 times. So 27 is basically 3 to the third. So we're going to have 3 to the third raised to the 5/3 power. Okay, so let's express this power as a fraction too. So whenever you have a power of a power, you just simply multiply powers. So you're going to have 3 to the 15 over 3. Okay, what is 15 over 3? 15 goes into 3. 3 goes into 15 5 times, right? So this is going to be 3 to the 5th power. Alright, so what's 3 to the 5th power? 3 to the 5th power, 3 times 3 times 3 times 3 times 3. You can do this in your calculator. This is 9 times 9 times 3, or 81 times 3, which is 243. Alright, so your answer is C. Alright, let's move on to question number 14. On question 14, we have to find the approximate value of log of 32, given the fact that log of 2 is equal to 0.301 and log 4 is 0.602. So to do this, I just need to express 32 using a combination of one of these two. So let's break down 32 as much as we can. So I'm going to use 2 to break it down. So 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. 1 2 3 4 5. So 32 is 2 to the 5th power. So I can express log of 32. Remember, if you do not have a base, the default base is 10. This is a common logarithm, okay? Equals log of 2 to the 5th power. Okay? I know what log 2 is. I don't know what log 2 to the 5th is. So what I'm going to do here is power down, okay? Using the quotient property. I mean the quotient property of logarithms. I'll just power this down. and then this is going to be uh, 5 log 2, like this. And then now log 2 is 0.301, so this is going to become 5 times, replace this log with 0.301. Okay, so just multiply 0.301 times 5. That's not difficult to do. If you multiply it out, you can use your calculator. You're going to have 1.505. Alright? And the correct answer here is option A. There are other ways you can do this. You notice I didn't use log 4 for this problem. It's not necessary. I can just use log 2 to finish this problem off. Okay? So there you have it. Alright, number 15. Find the exact value of the inverse cosine of negative 1/2. So for this one, we're going to consult our table of common trig angles. Let's bring that up. Cosine on 1/2. So what I'm going to do, alright, so we're looking for cosine, inverse cosine of 1/2, negative 1/2, I'm sorry, let's write that down. Inverse cosine of negative 1/2. So this is cosine right here. And we need to find where negative 1/2 is. Wherever they are, I'll just trace it up to the angles and that should be my answer, okay? So let's look for negative 1/2. So this is cosine, this is the first negative 1/2, and this is, wait, where is the second one? Yeah, there goes the second negative 1/2. So if I trace this to them, trace this to this angle right here, and also trace to that, our answers are either going to be 2 pi over 3 or 4 pi over 3. Okay, so I have two candidates, and I'll look at my options, whichever is 2 pi over 3 or 4 pi over 3, that will be my answer. Okay, so let's go back. 2 pi over 3 right here, our answer is D. Alright, moving along, number 16, convert 7 over 10 pi to degrees. So we have a conversion factors, which are pi over 180 or 180 over pi. So the question is, which one do we use here? So we have 7 pi over 10. Notice how I put the pi next to the 7, because if you're multiplying it by the numerator, okay? Now, since you have a pi on the top, you pick the one with a pi on the bottom so that the pi's cancel out, and you left with degrees, okay? So these zeros divide out. Let's see the pi and the pi here, they divide out to 1. 7 times 8 is 18 is the same thing as 70 plus 56, which is 126 degrees. The answer to number 16 is D. Alright, moving along, question 17. Bacteria and culture are growing exponentially with time, as shown in the table below. Which of the following equations express the number of bacteria y present at time t? So we're going to use the formula y equals a sub 0 r to the t. Okay? A sub 0 is the initial amount, and then r is the rate. You can find these by dividing the a1 divided by a0 or a2 divided by a1. Okay, dividing an amount by the initial by the previous amount will give you the rate. Okay, and then t is time. All right, so let's find out what these values are. Plug them into our equation, and then that'll be our answer. Okay, so what's the initial amount at day 0? A sub 0 is 200. What is the growth rate? How does it what do we keep multiplying by every single time? Well, let's see. I can do a1 over a sub 0 or 800 over 200. If I divide that out, that's 4. So it gets multiplied by 4 every time. So if I plug in 204 into this equation right here, that's going to give me the equation of the bacterial growth, which is going to be y equals initial amount 200 times the growth rate, which is 4 raised to the t power. Okay, so the answer to this question is A. Alright, moving along. Question 18. Find the exact value of 2 times cosine negative 3 pi over 4. 2 cosine of negative 3 pi over 4. Alright, so let's see. We need to find what cosine negative 3 pi over 4 is first and then multiply by 2, okay? So cosine, using our table of common trig angles, cosine inverse negative 3 pi over 4. Since we're dealing with negatives, we're going to go downstairs here. These are negative angles, and this is negative 3 pi over 4 right here. So where do they meet? You can use your fingers to find the connecting point, okay? All right, so let's join them. I'm going to use my line tool here. It goes right there. This is where they meet. They both meet at negative roots 2 over 2. So the cosine of 3 pi over 4 of negative 3 pi over 4 is negative roots 2 over 2. So this is going to become 2 times negative roots 2 over 2. All right, these 2's divide out, and your final answer is negative root 2. All right, so answer to the question is negative root 2, option D. All right, okay, moving right along to question 19. Find the value of the inverse cosine of negative root 2 over 2. So let's go back to our table here. So we're looking for the inverse cosine of negative root 2 over 2. So all we just have to do is identify negative 2 root 2, negative root 2 over 2, and cosine, and then see what angles give us those output values, okay? So we're looking at cosine. This is the row we're looking at. This is the first negative root 2 over 2. There goes another one. So which angles can give me these output values? So I'm just going to go from top down. Either 3 pi over 4, negative 5 pi over 4. If it were negative, it could be negative 5 pi over 4 or negative 3 pi over 4. So we have 4 possible candidates right here. If you look at the choices, they're all negative. So the 2 candidates we have are as follows. Either is going to be 3 pi over 4, which is equal to 135 degrees, or 5 pi over 4, which is equal to 225 degrees. So which of them is the correct option? Let's go back. So we have 135 degrees, and we also have 225 degrees. So this question has 2 correct answers. There's a typo here, but on the test, there's going to be only 1 correct one though. But in this case, we have 2 correct answers here. All right. All right. Moving along to number 20. We have to graph cosine, graph that curve on this interval. Okay. So what I want to do is I'm going to write this in transformational form first. Okay. So it's going to be y minus 0 equals 2 cosine. What can I can factor out a 1 since there's a 1 here. Take out a 1. You can have a coefficient for the x plus pi over 4. Okay? Alright, so what's the new origin? New origin. The new origin is, you do the opposite of that, negative pi over 4 and 0. So that means your phase shift, since you have a negative in the x, is going to be pi over 4 units to the left. Okay, because of that negative there. The vertical shift is going to be none. Okay, because you're going either up or down. Because y is 0. The amplitude is the absolute value of a, which is 2 in this case. The period is 2 pi over b. In this case, b is 1. So b right. This is your b right here. This is b and this is a. And just 2 pi. Alright? Okay. We don't need frequency to generate the graph, so let's not bother with that. So let's look at these graphs. Center is negative pi over 4 and 0. So the centers are going to be, this is negative pi over 4 right here. Between 0 and pi over 2, there goes the center, 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 center. Okay, so this goes our center. Now I'm going to draw my new, I have a new y-axis because my center got shifted to the left. So there goes my new y-axis, there goes my new y-axis, there goes my new y-axis, and there goes my new y-axis. Okay, Since we're graphing cosine, we're going to have the cups. Okay? Remember, for cosine, if you have that's your y-axis, you're going to have the cups like this. Alright, so which of these is a cup starting from your new y-axis? So taking a look at your new y-axis, we can identify what each function is. This clearly is going down and making an S. This is a negative sign. This is going up and making an S. This is positive sign. This is a cup upside down. This is negative cosine. This is a cup going, a cup that's facing up. This is positive cosine. So our answer is option D. Okay? Alright. Let's move on to the next one. Question 21. It says condense the log expression. So before we can condense, we have to create uniformity, right? We have to create uniformity. So how do we create uniformity here? We have the first and the last logarithmic terms are both log 7. They don't have coefficient. This has coefficients. So we have to deal with this 2 right here. So we're going to use the exponent property of logs just to power this up. Okay? So now this is going to become log base 7 of 2 plus log base 7 of v squared. Okay, anytime this becomes a power, it becomes an exponent. Okay, minus log base 7 of v plus 4. Okay, now remember, whenever you are adding logs, you're multiplying the numbers, and anytime you're subtracting the logs, you're dividing the arguments. Okay. So since we're adding these 2 logs, that means these are the arguments. Don't touch the base. That means these 2 arguments are going to be multiplied by each other. So we're going to have in the numerator log base 7 of 2v squared. And then this argument right here, you have a minus, so this is going to be divided. So it's going to be divided by v plus 4. Alright? So there you have it. So this one is option letter A. Alright, moving along. Number 22. We're supposed to find the angle of elevation to the largest animal, and this is x. So what is this x value right here? So we're going to be using SOHCAHTOA. So the question is, which of them is applicable to this situation? So since this is the angle, that means this side right here is going to be your opposite. This is going to be your hypotenuse. Okay? This is supposed to be 17. So that's your hypotenuse. The adjacent is right here. I don't need it. I don't know it. So scratch it. We don't care about that. 1h is sine for so. We're going to go sine x equals the opposite of a hypotenuse. Okay. Now how do I get x isolated? I need to get rid of the sine. So I need to use the inverse sine. Please do not divide by sine. Okay. You need to take the inverse of sine to get rid of sine. Okay. So you take the inverse sine of both sides of the equation. And then signs cancel out on the left. This one is inverse with that, so they neutralize each other out. You have x equals the inverse sine of 11 over 17. Now you just plug this into your calculator, and it gives you the final result. Okay, so let's plug that into the calculator. We have the inverse sine of 11 over 17. Final answer is 40.32. Okay? Alright, so x equals 40.32. Alright, moving along. Is this true or false? Well, let's see. We have 1 minus sine to the 4th theta. Let's simplify it as much as we can. Divide by 1 plus sine squared theta. Is it equal to sine squared theta? Since there's a difference of squares on the top here, I can factor it by rooting the first and the last and adding and subtracting the roots, okay? Because I know that a squared minus b squared equals a plus b times a minus b, okay? So this one becomes 1 minus sine squared theta times 1 plus sine squared theta divided by 1 plus sine squared theta. Okay. Now, is that equal to sine squared theta? Is it? Let's see. These two divide out, and then we have 1 minus sine squared theta. Is that equal to sine squared theta? If you use your Pythagorean identities, if you look at it, you find out that this is equal to cosine squared theta. So is cosine squared theta equal to sine squared theta? Absolutely not. So this is a false statement. It's false, false, false. Okay. All right. Last but not the least, is this true or false? Is cotangent square cotangent square b minus cosine square b over cosecant square b minus 1 equals cosine square b? Is it? Alright, so I'm going to express this using the quotient identities. I know that cotangent equals cosine over sine. And also the reciprocal identity cosecant equals 1 over sine. Okay? So on the top, this top part is going to become cosine b over sine b, actually square, minus cosine square b over 1. And the denominator cosecant is 1 over sine square b minus 1. Is that equal to cosine square b? Okay? Alright, so this one right here, we can find the LCD times it by sine square b. This one top and bottom, sine square b. Sine square b here. And then this one, I need to find the LCD, so I times it by sine square b top and bottom. Alright, remember, anytime you want to add fractions, the denominators must be the same. Alright, so this is going to become cosine square b over sine square b minus cosine square b sine square b over sine square b divided by 1 minus sine square b minus sine square b over sine square b. Okay? Is it equal to cosine square b? That's the question. Alright, so on the top I can combine the two. I'm going to have cosine square b minus cosine square b sine square b divided by sine square b, and then that whole thing divided by 1 minus sine square b over sine square b. Does it equal to cosine square b? That's the question. I notice I have a sine square b in the two denominators, so I can multiply top and bottom by sine square b to get rid of that identical denominator. So this divides with that, and this divides with that, and I'm going to be left with on the left side, I'm going to be left with cosine square b minus cosine square b sine square b divided by 1 minus sine square b. Is it equal to cosine square b? Alright, so on the top I can factor out cosine square b is common on the left and the right side, so if I factor it out, I have cosine square b times 1 minus sine square b over 1 minus sine square b. Is it equal to cosine square b? That's the question. These two are identical, so they divide out. So after they divide out, you're going to end up with cosine square b equals cosine square b. Okay? So the answer is true. The statement is true. Alright, so there you have it. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel by clicking up here. More videos can be found on myprecalc.com. Thanks again, and have a wonderful day.